Radiation in physics is the emission or transmission of energy as waves, particles, or both, via space or material medium. This comprises electromagnetic radiation, which includes gamma radiation, X-rays, microwaves, infrared, visible light, and ultraviolet radiation. Alpha radiation, beta radiation, proton radiation, and neutron radiation are examples of particle radiation, particles of non-zero rest energy. Acoustic radiation includes seismic waves, sound, and ultrasound, dependent on a physical transmission medium. Gravity radiation, which manifests as gravitational waves or ripples in spacetime's curvature. Depending on the energy of the radiated particles, radiation is frequently divided into ionizing and non-ionizing categories. More than 10 electron volts is carried by ionizing radiation, which is sufficient to ionize atoms and molecules and rupture chemical bonds. Due to the significant differences in how toxic these substances are to living things, this distinction is crucial. Radioactive substances that generate radiation in the form of helium nuclei, electrons or positrons, or photons are frequently sources of ionizing radiation. Other sources include medical radiography X-rays and the secondary cosmic rays created when primary cosmic rays impact with Earth's atmosphere. These particles include muons, mesons, positrons, neutrons, and others. The higher energy range of ultraviolet light, X-rays, and gamma rays make up the ionizing portion of the electromagnetic spectrum. The act of breaking one or more electrons away from an atom is referred to as ionizing, and it calls for the relatively high energies that these electromagnetic waves provide. A good example of this is sunburn, which is caused by long-wavelength solar ultraviolet. Further down the spectrum, the non-ionizing lower energies of the lower ultraviolet spectrum cannot ionize atoms but can disrupt the interatomic bonds that form molecules, thereby breaking down molecules rather than atoms. Although they cannot break bonds, waves with longer wavelengths than UV in the visible, infrared, and microwave frequencies can generate vibrations in the bonds that are perceived as heat. Biological systems are generally not thought to be harmed by radio waves and lower. There is some overlap in the effects of different frequencies, these delineations of the energy are not crisp. The phenomena of waves radiating, that is, moving outward in all directions, from a source is where the name radiation originates. This feature results in a set of physical units and measures that can be used for all types of radiation. The intensity of all types of radiation from a point source decreases with increasing distance due to the fact that such radiation expands as it travels through space and that its energy is conserved, in a vacuum. To the extent that the source resembles a geometric point, the inverse square rule, like any ideal law, approximates a measured radiation intensity.